This video is on systematic sampling. It is a commonly employed technique if the complete and up-to-date list of sampling units is available. And these are the usual notations. Here K is called the sampling interval. The variance of y bar sys is given by this expression where this s square wxy is the mean square units among the units within the same systematic sample, where this s square is calculated with this expression, right? It is the mean square among the units within the same systematic sample denoted as s square wsy. And if we compare the variance due to simple random sample and systematic sample, the difference between the variance is given by this expression. If in this expression, if this is positive, that is when s square wsy is greater than s square, variance of y bar n will be greater than y bar sys. Yeah, that is in this case, systematic sampling will give more efficient estimator. So when s square is wsy is greater than s square, systematic sampling is more efficient. Now we try to give variance of y bar sys in one other notation, that is in terms of rho, in which is the intra-class correlation coefficient between the units of the same systematic sample. Again, this is the expression in terms of rho. This is the expression in terms of s square wsy. Right? If this rho is greater than minus n minus 1, that is when rho is equal to minus n minus 1, this is the minimum value of rho, right? If rho is greater than minus n minus 1, variance of y bar sys will be greater than 0. If rho is equal to minus 1 by n minus 1, variance of y bar sys will be equal to 0. Right? Now let us compare the efficiency of systematic sampling and the simple random sampling. That is, we are computing the efficiency of systematic sampling with respect to simple random sampling without replacement. So this is the ratio, right? This is efficiency of systematic sampling with respect to simple random sampling without replacement. This is the ratio. And this is the expression. If rho is less than 1 by nk minus 1, your e value will be less than 1, which implies variance of y bar sys is less than 1, that is systematic sampling would be more efficient. If rho is greater than minus 1 by nk minus 1, simple random sampling would be superior. If rho is equal to 1, your answer will be, if answer for e will be k minus 1 into nk minus 1. Okay, right. Now let us try to give the variance of y bar sys in terms of one other parameter called rho wst, which is the correlation between deviations from stratum means of pairs of items that are in the same systematic sample. This is done with the idea to compare the variance of y bar sys with variance due to stratified random sampling. This is the expression. This a square wst is called the pooled mean squares between units within strata. Now the efficiency of systematic sampling with respect to stratified random sampling, the expression is this, which is derived using rho wst. If this rho wst is greater than 0, e dash is less than 1, which means stratified random sampling is better. If rho wst equal to 0, both of them are equally efficient. If rho wst is less than 0, e dash is greater than 1, so it means simple systematic sampling is better. Okay, so with this idea, let us go to today's questions. What is the formula for sampling interval? Sampling interval k is computed as n by n. Which of the following is an expression for variance of y bar sys? This, the first one, variance of y bar sys is n minus 1 by n s square minus n minus 1 into k by n s square wsy. So what is the formula for s square wsy? S square wsy is this, 1 by k into n minus 1 double summation yij minus y bar I dot the whole square. If s square wsy is greater than S square, which of the following is true? If S square WSY is greater than S square, variance of Y bar n will be greater than variance of Y bar SYS. See, variance of Y bar n minus variance of Y bar SYS is this. If this is greater than 0, it means this is greater than S square, so this is true. Okay. If S square WSY is equal to S square, which of the following is true? Simple random sampling is efficient, systematic sampling is efficient, both of them are equally efficient. If this becomes 0, what happens? The variances becomes equal, so the both the methods give equally efficient estimators. If variance of SYS is equal to 0, when this variance of SYS is equal to 0, right? For what value it is equal to 0. So, variance of SYS, Y bar SYS is equal to 0 when right? Rho is equal to the minimum value. When rho assumes the minimum value minus 1 by n minus 1, variance of Y bar SYS becomes 0. See, if you put minus 1 by n minus 1 here, n minus 1 and n minus 1 gets cancelled. So you have 1 minus 1, which is 0. So variance of Y bar SYS will become 0 when rho is equal to minus 1 by n minus 1. Okay, right. Next, when systematic sampling would be more efficient than simple random sampling without replacement. So this we have discussed here. Yes, systematic sampling would be more efficient than simple random sampling without replacement when this is true. Rho is less than nk minus 1 over nk minus 1. So this is true. When simple random sampling is more efficient than systematic sampling, when this is true, when rho is greater than minus 1 by nk minus 1. What is the value of E, the efficiency of systematic sampling, when compared to with respect to simple random sampling without replacement, when rho is equal to 1. When rho is equal to 1, see, when rho is equal to 1, we have derived it as k minus 1 by nk minus 1. So B is the correct answer. What is the expression for variance of Y bar SYS in terms of rho WST? This is correct. Okay, first formula is correct. Everything is based on these three formulae. Okay, so you make a note of these three formulae and try to answer these questions. Give expression for E, the efficiency of systematic sampling with respect to stratified random sampling. This is correct. See, let us try to remember this formula and answer all these questions, right? When rho WST becomes 0, what happens? This term will go off and E dash becomes 1 by 1. The efficiency becomes 1 by 1 is equal to 1. Okay. When rho WST is greater than 0, the denominator will be greater than the numerator. So your E value will be less than 1. Okay. E value will be less than 1. When rho WST is less than 0, the denominator becomes less. 1 minus something, it becomes less. So in that case, E value will be greater than 1. So for 15, when rho WST is less than 0, the E value will be greater than 1. Okay. So this single expression is enough to answer all these questions. Make a note of all these things and try to understand. Okay.